today's last presentation, Anton Klimonov Igorevich from Mendeleev University of Chemical Technology from Russia. Please start your presentation.
Good afternoon, dear colleagues and participants of the conference. It's a great honor for me to be here in Paris and have the opportunity to present my research work. I would like to share with you my research work about some ANRORC-type reactions in the chemistry of 5-membered heterocycles containing 3 heteroatoms. Derivatives of triazole thiols have a special place in modern medical chemistry. For example, lesinurad, the Chinese drug that used to treat hyperuricemia associated with gout, recently entered the market. Another one, triazomate, used as an insecticide to control aphids on agricultural crops. Triazole thiol derivatives also can be used as anti-tuberculosis drugs. For example, PDST drugs are also known. Additionally, substances like Russian drug triazoverin can be used as antiviral agents. Our scientific group also synthesized triazole derivatives using the classical method described in literature. We were able to obtain many substances with fungicidal and other activities, as evidenced by previous report of my colleague Grigory Tsaplin. Also, number of compounds were patented. In the chemistry of heterocyclic compounds, several similar rearrangements have been observed. For instance, dimer rearrangements, which involves the exchange of endo and exocyclic nitrogen atoms in triazoles. Other arrangements like cossagetulin or comfort are also known. My work aims to develop a new approach to the synthesis of triazole derivatives using ANRORC-type reactions between tia or oxadiazoles and the various amines on a single-step reaction. This new method would be simpler and less toxic compared to the classical pathway involving the condensation of thiosemicarbazets, which are derived from limited available thioisocyanates. By using this approach, we hope to expand the range of compounds available and find new and useful substances. The reaction mechanism is pretty simple, based on its name. It involves the nucleophilic attack of a carbon atom, which then opens the ring, removes the leaving group, and closes the ring again. To study the reactions, we first prepared oxa and thiodiazoles as a starting materials. We did this by reacting the corresponding acid hydroxides with carbon disulfide to form potassium salts. And then we cyclized these salts in order to obtain the desired starting material. After that, we started studying ANRORC-type reactions based on oxadiazole tions with various amines as examples. We used different alcohols as a solvents with different boiling points. We managed to obtain the desired products with good yields. Similarly, we started the synthesis of triazole derivatives from various thiodiazoles. This reaction haven't been described in the literature at all, and we prepared 5-penyl and 5-pyridyl thiodiazole tions as a starting materials too. For phenyl derivatives, these reactions were successful under mild conditions. We use ethanol as a solvent, and we were able to obtain products with good yields. For pyridyl derivatives, the reaction was also successful, but required more tight conditions. We use normal propanol as a solvent. In my opinion, the following examples are more interesting because we used triazolyl methyl as heteroyl alkyl and amine groups as substituents. Surprisingly, these reactions were also successful, but albeit at higher temperatures. In any cases, reaction is not going on, unfortunately. As a result, we were able to develop a new method for production triazole with potential biological activity, and both oxa and thiodiazole react. The reaction proceeds with variety amines, and we see high selectivity of the process. Thanks for your attention.